Alright, so I thought I'd make another video here. This is a mystery question someone posted me. So 2 sine squared x plus 3 cos x equals 3. Alright, we've got a problem here in that it's got sine and cosine combined. So what we're going to do is we're going to make use of our identity. We should remember our Pythagorean identity. Sine squared x plus cosine squared x equals 1. We've got that from our unit circle. We know the x and the y coordinates. When you square them, give the hypotenuse there. The radius of the circle is 1, so we've got that. We're going to rearrange it. We want to get rid of sine squared x, get it in terms of cosine x, and then we might be a chance of solving this. So I subtracted cosine squared x from each side. I'd end up with sine x equals 1 minus cosine squared x, and we're going to replace that in our equation right now. So I've got 2 outside of 1 minus cosine squared x plus 3 cos x equals 3. Just expand that bracket and I've got 2 minus 2 cos squared x plus 3 cos x equals 3. Now hopefully by now you guys will recognise what I've got here is a quadratic expression, except instead of being in terms of x, it's in terms of cosines x. That's not going to be a problem. We can still solve it the same way, but that negative 2 in front of the cosine squared term is going to bother me. So I'm going to get everything over on the right hand side rather than the left hand side. So I add the 2 cosine squared x. I subtract 3 cosine x from each side. And I'm going to subtract 2 from each side, so 3 minus 2 is 1. Now hopefully you can all see how to factorise that. Remember, if you're not sure, you can add in this little extra working, let a equal cosine x. So then what I've really got is a squared take 3a plus 1 equals 0, which some of you, 2a squared take 3a plus 1 equals 0, which some of you will then find easier to factorise. If you've been practicing your factorising just to make sure you don't lose the skill with it, then hopefully you can factorise this one pretty easily. That's 2 cosine x minus 1 and cosine x minus 1. Check your expansion of negative 1 will give me the positive 1. 2 cosine x multiplied by cosine x, yeah, that gives me 2 cosine squared. Doing the outer and the inner terms, negative 2 cosine x minus another one, negative 3. I know I've got it right. What have I got now? 2 terms being multiplied together equaling 0. That's a chance for the null factor law to come into play. So either 2 cosine x minus 1 equals 0, or cosine x minus 1 equals 0. Simplifying those, I've got 2 cosine x equals 1, cosine x equals a half, or over on the right hand side there I've got cosine x equals 1. Well, whenever we're doing these problems, we're going to need a little bit of help from our best friend in maths, unit circle. First of all, cosine x equaling a half. My cosine axis is the x-axis, that's about a halfway to 1. Oh, I'm going to need 2 angles, one in the first quadrant, one in the fourth, because you can see they're the only 2 that have that half as their x-coordinate. You're also pretty confident that your best friend's little buddy is going to help with this one, because a half is a number you recognise. So double check what the graph looks like, what the best friend's little buddy looks like. 1, 2, root 3. That's the bigger angle, so it's only 1/3 of pi. The smaller angle, that'd be 1/6. You get a less amount if you've got 6 kids in the family sharing your pi. Alright, cosine equals a half, so it's adjacent over hypotenuse, so it must be 1/2, must be pi over 3, the angle I'm looking for. So on the left I've got x equals pi over 3. And then the other angle, that's 2 pi minus pi over 3. Well, 2 pi is 6/3. So if I take away 1/3, that must be 5 pi divided by 3 for that one. Then on the right hand side, cosine x equals 1. Well, 1 is right out here at the extreme of the circle. The unit circle, that's where it equals 1. So the angle there would be 0 or 2 pi radians. So make your answer look nice. X equals 0, pi on 3 Did I really write 5 pi on 6? That's pretty slack. I said 5 pi on 3 and I wrote pi on 6. That's dodgy. Always check your working, guys. 5 pi over 3 and 2 pi. Let's hope that helps. Cheers.